It's a pleasure to me to introduce you Dr. Nour. She holds a PhD in software engineering from the Universitat Politecnica of Valencia. She is now a senior lecturer at the Brunel University of London, and where she co-leads the Brunel Software Engineering Group. Her research focuses on developing software architecture techniques with method and tools and how to apply them to different challenging systems, including, of course, microservices. And I would also, again, warmly thank Nour for accepting my invitation to tell us about her research on microservice architecture reconstruction. And I'm not stealing any more time to her. And please, Nour, the stage is yours.
Thank you, Jacobo, for the introduction and for inviting me to speak. And actually you described a lot about myself, but today specifically, I'm going to present about the microservice architecture recovery approach that we've developed. You already, Jacobo, gave an introduction about myself, but quickly, some of my research history or my academic history. I graduated from computer science at Birzeit University in Palestine. Then I did a PhD from Universidad Politécnica de Valencia. And there I actually, in my PhD, used model-driven engineering to automatically generate code of distributed and mobile environments. And created this approach called Ambient Prisma, where you could design the architecture of distributed and mobile systems using this concept called ambient. Then I did a postdoc or research fellow at LERO, the Irish Software Engineering Research Centre. And that's where I actually started working on architecture reconstruction and through certain projects. And that's where many companies or industries were at the time approached us because they were facing problems in understanding and maintaining their legacy systems. So they needed to understand the architectures of their system. And as Jacob has rightly said, now I'm a senior lecturer in computer science at Brunel University, and I lead the Brunel Software Engineering Lab, where we are a group of academics exploring and doing research in different areas of software engineering and a set of PhDs. And we are always open for collaboration, so please contact us. As part of this work specifically on the MiSAR approach, I want to acknowledge Dr. Nour Shukran. She was my PhD student, and parts of the work that I'm going to be presented actually were part as well of her PhD dissertation. So for the agenda of today, I thought as well of giving you just a brief introduction of what software architecture recovery is. And then I wanted to motivate a bit, do we really need, or why do we need a microservice architecture recovery in specifically in the microservice area or microservice systems? Then I'm going to present and introduce to you how we developed our approach, the microservice architecture recovery approach, and present to you the approach itself, and finally conclude the presentation. So just to give you a brief overview of architecture recovery, usually in software teams, someone designs an architecture and the development teams develop the implementation, hopefully following this architecture. Now, usually this architecture that we have planned is we call it as the as-designed architecture. Sometimes it's not an architect, but it's the whole team that designed this architecture following certain practices. And as I said, the development team, they go and implement, and maybe sometimes due to time constraints or pressure, sometimes because there's junior developers, the actual implementation doesn't follow this as designed, and what we do have is something called as implemented architecture. And as you can see, this as implemented architecture is actually the architecture that is in the implementation. As you can see here, there are these dependencies that are not good practices, and they were introduced. And usually these are called architecture violations or inconsistencies. However, if you don't, maybe the development team usually thinks that they are following this as designed architecture, because maybe this is the one that has been documented, but they would never know that they are actually having this as implemented architecture. So this is where architecture recovery, or sometimes called architecture reconstruction, comes into place, where it's a reverse engineering process which you actually obtain the representation of this implemented architecture. And when we have this conflict between the as designed and as implemented architecture, this is where we have architectural drift and erosion. I suppose, Jacobo, you're very familiar with the with this image and the Tower of Pisa, but it's a really good example that how we can have technical debt or misconceptions, actually, because we don't really understand how our implementation has been developed, and this can influence negatively on quality attributes and the general quality of our systems. Now, in practice, do practitioners in practice really follow architecture recovery approaches? And we did a survey or a study with practitioners, and we asked them if they follow architecture recovery, and usually they don't really follow them directly, and usually they use informal practices. So usually they say that they follow code reviews, they add certain rules in the code to make sure that they are satisfying these rules. They use naming conventions, and they make sure that the architecture is communicated very well to the team. So they check the architecture, or they have a steering committee, an architecture steering committee. They train the teams so that they make sure that they know the architectural knowledge. However, even if you keep on communicating, if there's time pressures, if there's other concerns, you could still have these architecture inconsistencies. So, do we need our microservice architecture recovery? Now, I know many of us, or in this community, would know what microservice architecture is. So I don't want to enter into detail of, okay, what's the difference between a monolith and a microservice. But as we all know, microservices are loosely coupled elements that are independent of each other. And one characteristic of microservice systems is that there's continuous delivery, and usually it's an evolutionary architecture. So the architecture is growing, adding new microservices, etc. Okay, so many of us may think, okay, microservice architectures are just the microservices, but in real practice, we do have other infrastructural components that are necessary in the microservice architecture to coordinate and synchronize these microservices together. So we could have intra and interdependencies between these microservices. Another thing is that microservice systems, because microservices are very small, but the system in itself can be quite large, and we could have very large microservices. And there is a theory that we could have more inter-service communication. And as well, one characteristic of microservices is that each microservice can be developed by different teams, and each team can decide on the platforms and the languages that these microservices are developed in. So actually, it's very easy to lose the big picture in microservice architecture. There's a theory as well that you would need maybe more documentation in a microservice architecture than in traditional monolithic to not lose the big picture. So that's why we would see that having an architecture recovery approach is very useful in this microservice world. So this is where we developed the Microservice Architecture Recovery approach, which we called MiSAR. So MiSAR is an approach that supports the recovery of architectural models and looks at architectural aspects of microservice systems. When we developed MiSAR, we wanted to follow a systematic approach in the sense that usually when you develop architecture recovery approaches, you follow your experience, but what we wanted to do is instead is actually design some empirical studies where we actually can trace back the decisions that we've made in the design and development of MiSAR. Another characteristic of MiSAR is that it follows model-driven architecture framework. So it separates the implementation from the architectural model. And I'm going to explain a bit for those who are not aware of what model-driven architecture is. So model-driven architecture follows model-driven engineering, where the first-class citizen of the system is actually the models. And the idea is you have different abstract levels of models. And instead of just using the software code, the idea is you can use these models and analyze them. So one of the important models that you have in a model-driven architecture is the platform-specific model, which is an abstraction of the system, still by using the languages and the platform that this system follows. Then you have the platform-independent model, where it's an abstraction of the system, which is a model that is completely independent of the technology. So it is described in a technique without describing the technology that the system follows. And the objective is you can transform from one model into another using model transformations. So in this slide, you can see the different abstraction levels of the MiSAR and how MiSAR actually supports the recovery of architectures. So we have the text or code level artifacts, which represent the microservice system, which in MiSAR currently we support Java, Docker, and Spring. So we have these kinds of text files. And then using a parser, we move to a higher abstraction level, which is the platform-specific model. Now, to be able to create models that are platform-specific model, we had to define a meta model that each model of a system are an instance of these meta models. And then the architectural model of the system is actually an instance of a platform-independent meta model that actually we had to define. So each time we create an architectural model of the microservice system, we are actually instantiating the platform-independent meta model. So as I said, one of our objectives was actually to define MiSAR in an empirical way. So what we did is we defined different studies that eventually defined the artifacts that would allow us to semi-automatically generate the architecture of systems. So in the first study, our aim was to identify what are the concepts that we need to represent of the microservice-based systems in the meta models and identify what are the mapping rules. So when we started defining MiSAR, you have to consider as well that it was like we started in 2015, and it was when microservice was actually emerging. And actually, we tried to do a literature review at the time to see if we could find some meta models that we could use and start with those. But actually, we didn't seem to find any meta models at that time. So we decided we should define these artifacts. Then in the second study, what we wanted to focus on is, okay, now we have a set of metamodels and mapping rules. Can we use them to semi-automatically recover the microservice system? And if necessary, should we enhance these metamodels and mapping rules? So in the first empirical study, what we did, we selected 8 open source projects. Parts of the characteristics or the criteria to select these open source projects was that we wanted that they that they had some documentation that could help us in the process. And this study actually involved us to manually recover the architecture of these systems. And what we did is we defined the steps of the study, and we defined one phase, which was the recovery design, and then the recovery execution. In the recovery design, as I said, we took the microservice-based system and we did a manual recovery by first of all extracting data and gathering it. Mainly our data in the microservice-based systems were the source files of the system. Then we classified and analyzed the file, the sources, and then we abstracted away and determined what are the architectural concepts. And in that case, a conceptual map helped us a lot in this process. And then after that, what we did is based on some literature review, we identified what microservice concerns and technology. So what kinds of patterns could be there that we have to consider in these systems. After having the architectural concepts and this, what we did is we clustered and integrated them, and we defined our first version of a meta model. And at the same time, we defined and extracted these mapping rules from the source to the architecture concerns. Then in the second phase, once we had an initial meta model and mapping rules, we applied other case studies and refined these artifacts incrementally and until we had architectural model views of these systems. So as part of the results of this study, we had an initial PIM meta model, which, as you can see here, the microservice is the core element of the meta model. And we divided the microservice into 2 types, infrastructure microservices and functional microservices. And each microservice has a service interface, and the service interface has a set of service operations. And each 2 microservices have service dependencies. Now, I want you to have a look at this as well. Initially, in this part, we had classified like these APIs or registry and discovery elements, tracing elements as infrastructure microservices. So this is not our final version because this is one of the versions. And as well, we defined a platform-specific meta model that represented the technologies that we supported in the systems, the microservice systems. As I said, we pass statically our systems from Java, Spring, and Docker. Now, in the second study, okay, now that we had an initial meta model, what we did is we wanted to use that meta model and these mapping rules to recover architecturally the systems. So we took another 9 microservice projects, and we designed another empirical study where we had the initial meta models and mapping rules that we obtained from the previous study, and we applied these meta models and mapping rules and apply them into different increments where we refined these meta models. And then after that, we implemented the meta models, the platform-specific model, and the PIM, the mapping rules, we implemented these artifacts to be able to semi-automatically recover the architecture of microservice systems. So after this study, actually, what we did is we actually refined our initial PIM meta model to become more expressive. Another thing, in the new systems that we selected systems that had, for example, in the first study, we only had synchronous communication in the systems. In the second system, we had systems that had more patterns and more communication styles. So in this case, what we did actually, we defined this message destination type where we had this concept called endpoint for synchronous communication, but as well, we provided a concept for queue listeners to represent the asynchronous communication. But we did as well decide that maybe as new communication styles appear, maybe there will be new types. So in a way, this message destination can abstract away, and if there's new types, we can extend our meta model in the future by adding a new concept here. Another change that we did in this meta model was that we defined a new concept called infrastructure pattern components that represented the different pattern components that different patterns would need, like API gateways, circuit breaker. And as well, we divided this pattern component into infrastructure server component and client component, because a microservice could use this component as a client or as a server. So we represented these. Now, once we had this, let's say, version of the meta models, as I said, we implemented them in eCore using the Eclipse modeling framework, and we also implemented mapping rules using the QVT transformation language. The implementation of the mapping rules, what it helps us is that you can now automatically transform from a platform-specific model into a platform-independent model. So here, what you can see in the slide is the steps of the MiSAR architecture recovery. So you have the microservice-based system that where we have a parser that collects the artifacts, the Java, the YAML and XML files, and passes and produces the platform-specific model. After that, you apply the transformation engine, or you execute the transformation engine, and you create an instance of the platform-independent model. And who is aware of model-driven architecture? This platform instance of platform-independent model usually is an eCore representation. So as well, we implemented a step where you can actually transform the graphical or the eCore model, the platform-independent model, into a graphical view. So in terms of application and evaluation of MiSAR, we applied MiSAR into different case studies. This is one of the case studies where we applied MiSAR to, which is the train ticket. Train ticket is also an open source project, which is a benchmark that has 69 microservices. And as well, train ticket is well documented. It has really clear documentation. And one as well aspect of train ticket is that these 69 microservices are not just developed in Java. So as I maybe said before, MiSAR supports the parsing of microservices that are developed in Java. So what we wanted to see as well is evaluate, okay, in a real microservice system, you have microservices that are implemented in different languages. So how would MiSAR behave in this context, which is a more realistic context? So just to show you, this is the parser of MiSAR, where you can select all these files. So you have the select Docker compose files, the different of the project, of the ticket, train ticket. And this parser would generate this platform's specific model instance. Okay, so after that, we execute the model transformations and we produce this platform-independent model instance. And as you can see here in the platform-independent model instance, it produces certain types of microservices. So here we have an infrastructure microservice called Redis. Here we can it has recovered a functional microservice called TS user service. And if you notice, some of the microservices that were recovered only have microservice. They don't have a type. I'm going to come to the explanation of why is that later on. But as you can see, we recover all these microservices. And eventually, as I said, to make it easier for developers or users, we also provide an additional tool where you can import the PIM generated model and generate a UML view of the model of the model in a graphical way. Now, one issue that you can face is because the microservice system is large, actually, the view cannot be very well viewed. So actually, we also provide a microservice level view where when you import the PIM, it will show you all the microservices that this model has, and you can select the microservice, so you can also have a view of just the microservice part for visibility purposes. So just in terms of quantitative results of the semi-automatic recovery process, so for train ticket, we recovered the 36 instances of the functional microservices and 27 instances of infrastructure microservices. Now, there were 6 instances of the microservices that we didn't really recover if they were functional or infrastructure. And I showed you some of the examples of the in the PIM instance. Now, the reason for that, after we check that, is that these 6 microservices were not Java projects. And as I mentioned, we statically parse the microservice system. So this is the reason. But the good thing is at least we can identify that there is a microservice, even if we cannot currently identify what type it is. Another thing that we wanted to do is compare the architectural model that we've produced with the documentation of that was documented by the developers of Train Ticket. So one thing that we discovered is that in the architectural model that we had recovered through MiSAR, we identified more architectural elements compared to the documentation. Now, the reason for that actually, and this is one of the interpretations, is that sometimes when you manually document an architecture, there are many details that you won't document. So when it's automatically recovered, and because MiSAR had many elements, so for example, endpoints that weren't really documented in the documentation, and which MiSAR really was able to automatically generate. Another thing that we discovered is that there were inconsistent elements between what MiSAR automatically recovered and the documentation. What we did in these cases is we went to the implementation of the system and checked, was MiSAR accurate or was the documentation accurate? And actually what we discovered was that it was the documentation that was that didn't really have the correct representation of the system. So why would different interpretations for that would be that maybe there was some drift. So maybe the developers continued developing the implementation, but they didn't update the documentation of the architecture. Or actually there was a misconception of so whoever documented the architecture really had misconceptions of the implementation. However, you will never know that. And that's why we need architecture recovery tools that actually would identify these inconsistencies. Now, as I said, there were missed elements that we didn't identify. and mostly they were related to the infrastructure pattern components. So as I said, we statically parse. So there was like elements, for example, tracing infrastructure elements implemented in Jaga, which MiSAR doesn't really doesn't have any mapping rules for. So we really missed these kinds of elements. So some conclusions. The conclusions with this is that we were able to do some kind of conformance checking with the automatically generated MiSAR architecture model in comparison to the documentation. And MiSAR was able to actually have an up-to-date representation of the implemented system. Another thing that we believe is the expressiveness of MiSAR in the terms of having different elements for having asynchronous communication or synchronous communication, and as well having different pattern components that usually if you just manually document, you wouldn't maybe represent these. And another positive aspect that we found is that even if MiSAR doesn't discover the existence of the whole architecture, and mainly when microservices are not developed in Java, we still have the ability, so MiSAR has the ability to discover these, the existence of these microservices. So as future work, there's lots of future work, actually. We are always updating our toolings and our implementations as we go along. But as well, in terms of, let's say, research future directions, what we would like is actually to provide, so as you can see from the work that we did, we could check, we checked manually if the architectural models were consistent or inconsistent. However, we would like to have an approach where you can check conformance and consistency automatically with as designed architecture models. And actually, I think Hajra, one of my PhD students, she's working on this area, and hopefully one day maybe she can give a talk in the future in the microservice community about this area. But as well, future directions, using these architectural models, it would be really important to provide ways where you can analyze and use these models to analyze quality attributes or check the security properties of the systems. And another important area that I think is important is to include these architecture recovery approaches as part of the auditing and quality assurance process of industrial practice. So at the moment, they seem like to be standalone tools, but if we can add them as part of the quality assurance and auditing of what software engineers use usually, that would be a good way. So this is what I wanted to talk to you today. So thank you all for listening to me, and I'm happy to answer any questions or have any discussions.
Thank you, Nour, for the very interesting talk. And yes, now it's time for questions. So let's see whether we have from the audience, but we already have one. Please, Fu.
Yes. Yeah. Hi, Nour. Hi, Jacopo and everyone. Yeah,
Hello.
thanks for organizing this webinar. I like it very much with the community that we are doing, and this presentation is very nice. I think I learned a lot from it. Thanks a lot, Nour. So my name is Fu from Syntep, and I think we at Syntep we also working with kind of cloud native microservices, and a bit to a previous project that we had. It was about the customization of cloud native microservices system as those systems that as a service, but a bit relevant to what you talk today, because I think in what we see in our work with industry, especially some software vendors in Norway that we have. They are adopting very heavily, the DevOps practice, and I think that the tool that you have here is very very nice, and can be have a huge potential for that. But in terms of the DevOps practice, so do you think how would you integrate your tool with that kind of practice? Because that is very important for, like, if they want to do it continuously, monitoring the implementation and have the support for that. I think that would be very nice.
Yeah, that's a really good question, and I try to highlight it in our future work. Actually, this is a really because yes, you don't want this tool to be or these kinds of tools, and how can I call them, like doing offline tools.
Yeah.
You want them to be
Yes.
part of the general practice, and one way of doing that is actually to support not just recovering at one stage, but actually having a recovery process from the start and actually doing checking as you are developing. So in a way, it's not like you have the system. This is my idea, yeah? So usually you have the system already developed, and actually most of the evaluation we've done is on that. So you have the system that is being developed, and then you try to recover the architecture later on once the system has been developed. And as I see it, it should be just in time. So in the sense that while I'm evolving my system and while I'm adding new microservices, while I'm changing the code, I actually am checking the consistency of my architecture and the conformance of my architecture to certain patterns and certain rules. So that's how I actually see how we can incorporate this as a process. So yeah, it's not that would be my idealistic way of using it in a continuous delivery way. And actually, part of the survey that we did with the practitioners, they did suggest these kinds of ideas.
Yeah.
And another thing is, for example, when you do a commit in your repository, yes, as part of that commit, actually, should I check the architectural rules? So not make it, yes, after, you have this, the system that is a legacy and you start doing all of these implementations. Actually, it's incorporating it when you're doing the quality assurance, when you're testing in the whole process of your development.
Yes.
Yes, and as well have some kind of version control, maybe. So where everybody can see the model. So have the whole team see the model and see how the model is evolving. So have the as implemented architecture really visible to everyone in the team.
Yeah, that could be very nice.
We did some kind of work actually with not microservice architecture in our previous approach, which is called GTAC. I don't know if you've heard of it. It doesn't support microservice systems, but I would really like this these kinds of approaches to become more evolution, more adaptive, more integrated into the continuous delivery.
Yes. I think I like also the point you mentioned about security check as well. I think that is also what we plan. I mean, we at our work, we know that it's important. We are also working on it as well. A bit of quick follow-up question, if I may, in the current kind of platform specific model that you support for is mainly Java based kind of system, right?
Yes.
And if we kind of want to extend the tool and so on for another system like .NET Core or whatever, then you still need to also implement again the transformation for that as well.
Yes, you would need to create new mapping rules. Yes, for each so what doesn't change is the platform independent model, but you would have to you have to add new mapping rules from that technology into the platform independent model.
I also kind of worked with model transformation some times ago, and it's really inspiring to see that you're applying it, and I think I would now it's really kind of make me really have a big interest to do something in that direction again with model transformation, because I used to work a lot with that, but now it's a bit less.
Yes, I
Okay.
understand.
Yeah,
happy to work with you or collaborate with you.
Yeah,
Keep in touch.
I will keep in touch and with you, and we let's continue our discussion, hopefully at another event as well.
Yeah, thank you.
Thanks.
Thank you for the nice discussion. Are there any other questions from the audience? So we have one from Francisco. Please, Francisco.
Hi, can you hear me?
Yes.
Yeah. I'm interested in the microservice view, for example. That was one of the things that you mentioned. What type of information that particular view provides? Like maybe I can see the interaction that this service has with other parts of the system, or
yeah. So in the microservice view, you can see the microservice and how that microservice interacts with other microservices. So instead of seeing the whole architecture, you can see how that microservice, what are the service dependencies that it has with other microservices, its endpoints, and actually you can see what infrastructure pattern components that microservices, that microservice uses.
nice. That's exactly what I need. I think maybe I can try to look through the tool. And another question also is like, and what are the limitations of the current approach? Like what it takes for this type of tool to be fully automatic, for example?
This is a good question. Yes, we're not suggesting our tool is really commercial. We really have to improve on it, but we are very slow on that perspective. Yes. For now, it's we have the parser, we have the model engine, we have this graphical view all separated, and having one tool actually that encapsulates these different parts would be, I think, would improve the usability of our approach. That's from one angle. One aspect is the parsing as well. So depending on the size of the system, yes, the parsing can take longer or shorter. So just to give you, if I remember well from the top of my head now, parsing just train ticket takes like 3 minutes. Okay, so that's something that I think we have to improve. So in terms of the parser itself.
Okay. Thanks for your answer and for the nice talk also.
Thank you.
Thank you again. So is there any other question? Okay, so now it's my time because I have plenty of questions actually, but we are running out of time. So first, please let me recall to all of you that in 5 minutes we will have the Microservices meet and greet, which is an event that we can exploit for how can I say, for chatting about microservices and research if you wish. But going back to your talk, I see many. I think that we had been working on very similar things because we are also in PISA running a system for microservice architecture recovery, also for the analysis. And yeah, perhaps we can have a separate call and we can discuss, because I mean, in these 5 bullets that you are showing also with Francisco, 2 of them we are currently working on it. So maybe it's a good thing that we instead of doing stuff separately, we merge our forces and we find a way to cooperate on this.
Definitely, yeah, I would really happy to
then
see that.
We will have surely a follow-up, I think. So let me thank you all for attending the webinar. Let me thank again Nour for her very inspiring talk, and that's it, I think, for the webinar. Please keep connected, because I think our other people might join to the meet and greet.